Hello everyone, and welcome to this special episode of our science series. Today, we're going to be exploring one of the most exciting and challenging concepts in space exploration: interstellar travel. While we've made incredible progress in exploring our own solar system, the idea of traveling to other star systems and exploring the vast reaches of the universe is still a dream that scientists and space agencies around the world are working to make a reality. In this video, we'll be diving deep into the science behind interstellar travel, the challenges we face, and the exciting projects currently underway. The science of interstellar travel. Interstellar travel involves traveling to other star systems, which can be incredibly challenging due to the vast distances involved. The nearest star system to our own, Alpha Centauri, is over 4 light-years away. To put that in perspective, it took NASA's Voyager 1 spacecraft over 40 years to travel just beyond the edge of our own solar system. If we were to send a spacecraft to Alpha Centauri at the same speed as Voyager 1, it would take over 70,000 years to arrive. To make interstellar travel a reality, we need to develop propulsion systems that can travel at much faster speeds. There are several propulsion methods that have been proposed, including fusion propulsion. This involves harnessing the energy released by nuclear fusion reactions to propel a spacecraft. Fusion is the same process that powers the sun, and if we can harness it for our own use, we could potentially create a propulsion system that provides the energy required for interstellar travel. Antimatter propulsion. This involves harnessing the energy released by the annihilation of matter and antimatter to propel a spacecraft. Antimatter is the opposite of matter, and has the potential to provide the fastest propulsion method for interstellar travel. Solar sail propulsion. This involves using a large, lightweight sail to capture the energy of sunlight and propel a spacecraft. While this method is much slower than other propulsion methods, it requires very little fuel and could potentially be used for long-duration missions. Challenges of interstellar travel. The challenges of interstellar travel are immense and include distance. As we mentioned earlier, the distances between stars are vast, which means that even the fastest propulsion methods will take decades, or even centuries to travel to other star systems. Time. Even if we were able to develop a propulsion system that could travel at near the speed of light, the journey would still take years or even decades. This presents many challenges for the spacecraft and crew, including the need for long-term food, water supplies, waste management, and radiation protection. Resources. Interstellar travel requires vast amounts of resources, including fuel, food, and water, which would need to be replenished over long-duration missions. This presents a significant challenge, as resupply missions would be impossible due to the distances involved. Radiation. Interstellar space is filled with high-energy radiation that could damage spacecraft and harm crew members. Finding ways to protect the spacecraft and crew from this radiation is a significant challenge. Current projects. Despite these challenges, scientists and space agencies around the world are actively researching interstellar travel and developing technologies that could make it a reality. Some of the projects currently underway include Breakthrough Starshot. This project aims to send tiny spacecraft to Alpha Centauri using a powerful laser propulsion system. The spacecraft, which would weigh only a few grams, would be able to travel at speeds of up to 20% the speed of light. Project Orion. This project aims to develop a nuclear-powered spacecraft that could potentially travel to another star system within a human lifetime. The spacecraft would use nuclear explosions to propel itself, and could potentially reach speeds of up to 10% the speed of light. Project Daedalus. This project, which was proposed in the 1970s, aims to develop a fusion-powered spacecraft that could travel to Barnard's star, which is 6 light-years away. The spacecraft would use a fusion engine to propel itself, and could potentially reach speeds of up to 12% the speed of light. Starship. This project, led by SpaceX, aims to develop a reusable spacecraft that can transport humans and cargo to Mars and potentially beyond. While the initial focus is on Mars, the ultimate goal is to develop a spacecraft that can travel to other star systems. Interstellar travel is one of the most exciting and challenging concepts in space exploration. While there are many challenges to overcome, scientists and space agencies around the world are actively researching and developing technologies that could make it a reality. From fusion and antimatter propulsion to solar sail technology and nuclear explosions, there are many potential propulsion methods that could enable us to travel to other star systems. And with projects like Breakthrough Starshot, Project Orion, Project Daedalus, and Starship, we are already making progress towards this goal. While interstellar travel may still be decades or even centuries away, the dream of exploring the vast reaches of the universe is one that continues to inspire us all. Thank you for watching, and we'll see you in the next episode of our science series.